As emission regulations are becoming stricter and there is a greater demand for fuel-efficient vehicles, stop-start systems are becoming more popular. In this video, I'll be covering the components used and their operation. The stop-start system was developed to reduce emissions and increase fuel economy by switching the engine off whenever the vehicle comes to a complete stop. There are various names for stop-start systems, such as iStop, Auto Stop-Start, and Eco Stop-Start. This system continuously monitors various components and sensors to determine when the engine can be shut down. When the driver lifts off the brake pedal or depresses the clutch pedal, the engine starts and the driver can once again continue on their journey. The high electrical load on some vehicle systems, such as air conditioning, radio, headlights, and blower fan speed, may inhibit the operation of the stop-start system. This is not a fault. The system is ensuring that the battery will not drop below a predetermined state of charge. The stop-start can be manually deactivated if desired. Check all the prerequisites before diagnosing any system faults. When deactivated, a message indicating the system is disabled may be displayed in the instrument cluster, or the symbol may change colour. Once an ignition cycle has been performed, stop-start will automatically return to its default setting. Stop-start systems may utilise some additional components such as a high-performance starter motor and/or a transmission oil pump for automatic transmission vehicles. Some systems may also use an auxiliary battery. Sensor inputs can include brake and clutch pedal position, battery current, vehicle speed, coolant temperature, accelerator pedal, bonnet position, and door latch switches. Stop-start can be fitted to vehicles with automatic, manual, dual clutch or CVT transmissions. When the ignition is switched on, the orange iStop symbol will appear and then go out. When driving at speeds above 3 km per hour or 2 miles per hour, the iStop symbol will illuminate green. This indicates that iStop is ready for operation. A fault will be indicated if this does not occur. Other faults may be indicated by an amber flashing iStop symbol. When stopping the vehicle using a light brake application, the symbol will flash green. The flashing symbol indicates that the system is ready for engine shutdown. Pressing the brake pedal further will cause the engine to turn off. The iStop symbol will stay illuminated on the instrument cluster. While the engine is off, the BCM or body control module continues to calculate the battery state of charge via the battery current sensor. At the same time, an auxiliary transmission oil pump will be activated. This means a smooth takeoff can be achieved in an automatic transmission vehicle. If the blower fan is on, the HVAC module may decrease fan speed, therefore reducing battery current draw. This helps maintain the battery's state of charge. Once the brake pedal is released, or the battery state of charge drops below a predetermined value, the ECM or engine control module will command engine start. Any devices influenced by iStop will return to their previous settings. Let's have a look at a typical schematic for an automatic transmission vehicle. The current sensor supplies the BCM with current flow information to help it calculate the battery state of charge. This can be communicated via LIN bus or a pulse width modulated signal. The iStop control button is a momentary switch that supplies a ground to a pull-up circuit when pressed. This allows the system to default to its preset state when the ignition is cycled. The BCM also receives input positions from the door latch, bonnet, clutch, brake and seatbelt buckle. The BCM requests the iStop symbol to be illuminated in its various forms in the instrument cluster. Again, this will depend on the operating conditions. Processed information is sent to the ECM via the vehicle's communication network. The engine control module uses this data as well as inputs from the accelerator pedal, coolant temperature, crankshaft and camshaft position, ABS control module and transmission control module. If the conditions for successful operation are suitable, the ECM will disable fuel and/or spark to bring the engine to a stop. As the engine is no longer running, transmission fluid pressure will drop. To ensure a smooth takeoff, an auxiliary fluid pump is utilised to maintain clutch pack contact within the transmission assembly. This auxiliary fluid pump circuit is operated by a low-side driver in the ECM. Pump speed is regulated with the use of a pulse width modulated control. Feedback is monitored by a pull-down sensing circuit. I've connected an oscilloscope to the auxiliary transmission oil pump control and feedback circuits. The blue trace represents the pulse width modulated oil pump speed control and the red trace is feedback. When iStop is active and the engine turns off, the auxiliary transmission oil pump speed will be varied based on this feedback signal. Once the ECM commands engine start, the auxiliary pump is switched off via the ECM. When the driver decides to continue on their journey and releases the brake pedal, the ECM activates the control drivers to energise the starter relay. Under normal operating conditions, the engine will also restart if the BCM determines that the state of charge of the battery has dropped below a predetermined value, reverse gear has been selected, or the transmission has been placed in park and a door has been opened. On manual transmission vehicles, stop-start systems require clutch pedal and a neutral position input. When the vehicle is stationary with the brake pedal applied, the transmission needs to be shifted to neutral and the clutch pedal released. The ECM will deactivate the fuel and/or the ignition system to shut the engine down. When the clutch pedal is pressed, the ECM activates the starter relay for engine crank. There are several conditions that can inhibit the operation of a stop-start system. For example, having the air conditioning set on the lowest temperature, not wearing a seatbelt, or having the driver's door ajar, the hood not closed properly, or the battery's state of charge is below the minimal threshold. All of these things can have an effect on the operation of stop-start. Make sure you know the conditions applicable to your vehicle before diagnosing. Let's look at some of the safety features of the stop-start system. If the transmission lever is moved from drive to park, the engine will remain off. If the seatbelt is now unbuckled and the driver's door is opened, the engine will restart. This is a warning to the driver that the ignition is still active. With the engine off, iStop active, and the transmission in drive, releasing the bonnet, removing your seatbelt or opening a door will disable the stop-start system. The iStop light will go from green to orange and the dash lights will appear. If this occurs, a manual engine start will be required by the driver. The engine will restart when reverse is selected. The iStop symbol will extinguish as this function is not available in this gear. That's stop-start and its operation. It's important to understand how the system works and know what conditions can cause it not to function. Technology is evolving, and by keeping up to date will ensure you won't get left behind. Thanks for watching, see you next time.